Alright, so today we're starting with Module 9, Modifying Data. And specifically we'll be talking about add or insert, update, and delete functionality today and working with databases doing that. So by the end of this module, you'll be able to handle data entered on a form by a user and then use that data entered into the form to update a database table. You'll be able to insert a row, update a row, and delete a row. So we'll be looking at the form handling as well as the SQL that you'd need to be able to do all these tasks. So there's a screenshot of an application that's allowing users to modify, delete, and insert or add new rows. And we'll start out with the input or input by name statement this morning. So an input allows a user to enter or change values in a program record, which can then be used to add a new row to a database table or update an existing row. So that's the idea with this input statement. And you can tell by the header that there's kind of two forms of the syntax for an input. One form is required if your program variables don't exactly match the name of your form fields, your screen record. And if they don't exactly match names, then you have to use this first form of the input statement so that you can itemize or specify the names of your program variables here first, and then over here are our screen record members that we're associating those program variables with. And when we use the input statement like that, that dialog temporarily binds these program variables that we've defined with the variables in the screen record so that it can manipulate fields while the user is doing the input. So here's the second form of the input. This is the easy way to do it. If your program variables match exactly the form fields in your screen record, then you can use the input by name syntax. So input by name, specify, in this case, MR account rec, which is our program record. We've seen the without defaults clause, I think, a few times by this point. And what we're doing there is we're allowing the same input statement to be used for inserts of new data as well as updates for existing data. And that without defaults is going to prevent, let's say, defaults from the database tables that have been configured from being put into the form, possibly replacing data that's been put there by a user. So we're going to use that because we're going to use the same input function and form for an update. We've also seen this unbuffered attribute before, probably 2 or 3 times by now. So just to kind of remind you what that does, that makes the dialog, which in this case is an input dialog, sensitive to changes. Since we have this temporary binding between the program variables and our screen record, or screen variables, screen form variables, that didn't come out quite right, that means that anytime you change a value programmatically to the program record, it'll automatically be synchronized with the screen record and vice versa. If a user inputs some data into a form field, then that automatically gets input into the corresponding program variable. So that's what the unbuffered does. It makes whatever dialog you're working with sensitive to changes and automatically synchronizes program variables with screen records on the form. So here's a diagram of updating tables with embedded SQL, and specifically we're looking at this input statement, of course, since that's what we're talking about here. So here we've got a form that's been defined that has a screen record in it, and then we have a variable. We don't see it in this diagram, but we have a program variable defined that corresponds with the screen record, and then we have this input statement that allows the user to input data into the form, and then that, remember, can be automatically synchronized with our program record. And our program record is this crec.star. And then once the input's successfully completed and we have that program variable is filled in from the form fields, synchronized with the form fields, then we can use that information in the program variable to update this database table. So there's our SQL statement. Update country, set code description equal, there's our program record member code description, where code equals crec.code. And then over here's the corresponding database table that would be updating. If your database supports transactions, then there's a lot of cases where you should use transaction blocks in your application code. Particularly if you're working with multiple changes to a database that you feel like should be done as a group. That's when it's really important to use transaction blocks. Transactions and begin work and commit work statements that are part of transaction blocks cause the database to either perform all the changes between your begin work and commit work statements. They all get committed to the database, or if something happens in the middle there to one of the statements in between your transaction block, then it goes ahead and rolls back all of the statements. So it's particularly important if you're working with, let's say, SQL statements, for example, that work with multiple tables, like, for example, adding orders and items. We would probably want that to all be done as kind of a grouped transaction. So if we finish adding order information and we're in the middle of adding items for that order and something happens that causes it to fail, we don't want the order to be committed to the database without its child items. So that's the work of a transaction block. So if I put all of those SQL statements in between a begin work and a commit work, the database will ensure that either it all gets committed to the database or none of it gets committed to the database. So that's what we see here as an example of a transaction block. So we've got begin work, which is a standard. Most databases support begin work statement and commit work statement. If they support transactions, then this is the standard commands or the standard statements. So here we've got a begin work. We've got an update statement here to update the account table. And then we check the SQL code down here to make sure that the SQL statement was successful. And if the SQL statement is successful, then we're issuing a commit work statement. Something else about the transaction blocks and the commit work or the rollback work, if you use that, that is supported for some databases, and some databases don't support the rollback work. But when you use those transactions and you finish the transaction with one of those statements, commit or roll back, that also has the effect for most databases of closing cursors, right? So releasing the result set from a cursor and also releasing any locks that have been set for the rows in the result set. So just a bit more about the behavior for transaction blocks. Now, if you don't have transactions, if your database doesn't support transactions or you're not using transaction blocks, then each statement is treated as, I think, what they call a singleton transaction, right? So each statement is in itself a transaction. And when that statement completes, then it releases locks. Concurrency can be a problem. This chapter that we're talking about here, we're going to start talking about things like updates here in a bit. And anytime you start updating data, that requires locks. Anytime we insert or delete data, that requires exclusive locks. So anytime you're using SQL statements that create exclusive locks on rows in your results set, that can cause problems with concurrency, problems with the other users that might be trying to access the same rows in the database. So for a different SQL statement, your database uses a system of locks. Specifically, the statements that we're working with in this chapter, insert, update, and delete, all require exclusive locks on the rows to be able to update them. We don't want to worry about some other user trying to grab those records while we're looking at them. And in a way, we're protecting the other users from grabbing or retrieving a row that might be in the middle of being changed. So the locks are there for our protection while we're modifying a row or deleting a row so that nobody else can change the row while we're trying to change it, but they're also used for the other users to protect them from accessing a row that might not be a permanent row. You might be in the process of deleting it, or you might be changing it. And that keeps them from getting, let's say, a row that's not really a complete row. So the effect that these locks have on other users partially depends on something called the isolation level. Some databases, most databases, support something called isolation levels. There's also a set transaction instruction. So if your database doesn't support the set isolation statement, look to see if it supports something called set transaction. They're basically the same thing. The terminology might be slightly different. For example, we've got this set isolation to committed read that works, for example, with Informix, but then other databases have the syntax last committed. But as far as functionality, they work the same way. So different databases use different syntax. And by the way, we talked about the Open Database Interface, the ODI that Genero uses. In cases like this, where the terminology might be somewhat different, but there is an equivalent, then that's one of the jobs of our Open Database Interface, is to convert, for example, the set isolation statement to possibly a set transaction statement that your target database can understand. So that's one of the nice things about the ODI, that automatic translation when it can do it. So committed read is typically the default for most databases, or the equivalent of committed read for some databases, which means that it doesn't place a lock on a row that it's fetching or retrieving, but it does check to see if there is a lock already on a row. And if there is an exclusive lock on a row that it's trying to select or fetch, then a committed read isolation level returns an error by default back to the user that's trying to read the row that's locked. So that's typically the default for most databases, is the equivalent of committed read. For some things, you can configure an isolation level of dirty read if you like, and that avoids the whole concurrency problem of encountering a locked row and returning an error back to the user. It won't return an error back to the user. It'll go ahead and fetch whatever's there, but you may end up with something sometimes people call phantom rows, where you're reading these rows, but while you're doing it, someone is actually in the process of deleting one of the rows that you're retrieving. So it may appear to be there to your user that's using the dirty read isolation level, but while they're actually possibly looking at it after they've fetched, let's say, a cursor results set, someone else can get in there and delete that row, so it doesn't actually exist anymore. So dirty read is not a particularly safe isolation level, but you can use it for some applications. Perhaps a report, for example, that's just trying to get a good estimate of something, but it doesn't have to be exact. And we've got some additional isolation levels: cursor stability, repeatable read. Some of these isolation levels are proprietary or specific to Informix. So anytime you're working with a target database, you should always kind of look into that database's isolation levels to see which isolation levels are transactions with the set transaction statement are supported. We just said that the default behavior, if a user is using what's typically the default isolation level of committed read, and he goes out and he tries to retrieve a set of rows, and one of those rows is locked exclusively by another application, the default behavior would be to return an error back to our user that's trying to retrieve that locked row, and it causes basically a failure, right? He gets an error and he has to try again later, for example. There's something called lock modes that you can use to kind of control the effect of locks on your other users. Specifically, set lock mode to wait. Now the default is right here, set lock mode to not wait. So that's our default behavior, where the user would just get an error right away if there's a locked row in his result set. Right? He's trying to go out there and grab that locked row. You can also change it though to set lock mode to wait. And if you specify set lock mode to wait in the application, then instead of the program returning an error immediately when there's an exclusively locked row that it's trying to grab, instead it will just sit there and wait. And the possibility is that whoever has that row locked might just sit there and leave it locked for a long time. Let's say he gets a phone call or he wanders off to lunch for a while, and in the meantime our application with set lock mode to wait set is just sitting there with all the appearance of being hung. Now some of the databases have implemented solutions for that, to work around that type of a problem, but typically what we do is set lock mode to wait a certain number of seconds. So that's what the N represents. So instead of just waiting an indeterminate amount of time, which may be too long, you can use that. Set lock mode to wait, let's say 15, right? And for 15 seconds there, it will wait for a locked row to be released. But then if it times out, it will go ahead and return an error back to our user. And that way our user's not just stuck there waiting. So that's lock modes. It's not, again, supported by all databases. Some do support this type of statement and some don't. So back to our input statement, now that we've talked a bit about concurrency issues and locking and that type of thing, that sets us up to go ahead and look at the rest of the statements in the chapter. So in our input statement here, here's a function that's being used for inputs and updates to the account table. So when the user selects an action, either insert or add, whatever he selects, add or update, that sets a flag. They've defined a variable here called AU flag, which is a character 1 that's either going to be an A that gets passed into this function, which means that the user has selected the add option, or it gets passed in a U, which means that the user has selected the option to update. So that's how this function knows whether we're doing an add operation or an update operation. So we're going to come back to this, what we call a work record. This is just a program record here that's been defined. We're going to come back to this later when we start talking about updates. For add operations, we really don't need to use this, but I'll explain it all here later in the chapter. So here it's saying if the flag is an A, that means the user selected add, then we're going to give a message that says add a new account, and then we're going to null out our program record, mr_account_rec.star, by assigning it all the values of this work record. And the work record initially is all nulls. So that creates just a null record, this mr_account_rec program variable. Then down here, we're setting int flag. If you remember, int flag are a global variable there that we can use to determine whether or not a user initiates an interrupt. We're going to set that to false so that we can detect if the user cancels during the input operation. And then here's our input by name statement. And there's our without defaults and our unbuffered attribute, just like we looked at before. So that allows the user, in this case, of course, to add information that can be updated to the database as a new row or inserted into the database as a new row. The input statement, like all the interactive dialogue statements, has what we call control blocks that let you control the behavior of the interactive dialogue. So here's an example of why you might use one of these control blocks during an input. We've got onChange user ID. User ID happens to be the primary key for the account table. So during an add operation, it would be okay for a user to input data into the user ID field on the form, right? Because he's adding a new row and he needs a user ID for that new account. But during an update, we wouldn't want the user to be able to enter information into this user ID field because it's the primary key. And we don't let people normally update the primary key of a particular table. So here we're checking on change user ID. We're saying, okay, if the flag is add, right, if it's not update, it's an add, then I'm going to check and do a select statement to make sure that this user ID that this user is adding doesn't already exist. So it's actually checking for uniqueness. We don't want the user to sit there and enter this entire record and then have it fail at the end because he's trying to enter a duplicate row, right? Our table won't allow a duplicate. So this is a courtesy to the user, actually, to check it right away, right at the beginning of the input. And as soon as he puts that user ID in the user ID field, it's going to check, see if there's already a user ID that that matches, and if there is, that means he's trying to enter a duplicate. He's going to have to use a different user ID to continue. So that's what we're doing there with the on change. So those control blocks can be very helpful. And then finally, down here at the bottom, if the input finishes successfully, it's going to return, again, a flag letting the calling function know whether it's okay to continue or not continue with the input. And we'll see that again later. So assuming that the input was successful, right, nothing went wrong during the user's input of the data for a new row, this function gets called, function insert account, and this has our SQL to add a new row to the account table. And then down here, as you should always do, anytime you perform a SQL statement, it's a good idea to check the SQL code and see if the SQL statement was successful. So that's what they're doing at the bottom. So there's the insert. So we took the values that were entered into the screen record. Those were automatically synchronized with our program record, and then we used that to insert the row into the table. Right there, values mr account rec dot star. That's our program record. When you start working with updates, that's where we really have to be more concerned with concurrency problems, because updating rows in a table, a lot of times people will use what's called an update cursor. It's a very common thing, and by saying that this is option 1 and showing you option 2 here in a few minutes, I'm not trying to say that you should never use an update cursor, because lots of people use update cursors and they're perfectly happy with them. But you do have to be aware that an update cursor, between the select statement where it's fetching a row in and from the time the user is inputting changes for the update till when the transaction is committed, there's an exclusive lock on that row. So that's the reason I'm saying that it could have a concurrency effect, because this exclusive lock could be on that row for a good while the user's thinking about his changes and typing in his changes. That row is exclusively locked. But this method, again, is very common. So let's take a look here. Update using an update cursor. There's also a withhold option. Now that withhold option is proprietary, and it only works with Informix, so far as I know. It's not a common thing. And withhold has the effect of keeping the cursor open at the end of a transaction, which is unusual, right? Typically, when a transaction ends, like we perform our update and update the database table and commit work, that releases the result set. It closes the cursor. And then if the user wants to do another modification, he has to query again to do it. So that's typical normal behavior. But Informix has a withhold option. And the purpose of that withhold option is to hold the cursor open so that the user can make a change, do an update, complete a transaction, but the result set, the cursor, remains open. And that way, when he finishes one update, he can just keep scrolling and finding the next record that he wants to update. But again, it is proprietary. It's Informix only. All right, so that's the withhold. So an update cursor, I already mentioned, puts an exclusive lock on each row as it's fetched. Sometimes that's referred to as pessimistic locking, because we're concerned about somebody else coming in and grabbing that row before we have a chance to update it. So we're making sure they don't by locking it as soon as it's fetched. And we keep that exclusive lock until we're finished with it. The row then can be updated with the where current of clause. So it's just another SQL clause that you can use to do something called a positioned update, right? It already knows what row you're working with. It's the current row, and it just updates the current row as a positioned update. So some of the advantages of using an update cursor, well, since we've got an exclusive lock on that row from the time we fetch it with our update cursor, we know we're not going to have any problems with some other user coming in and locking the row in front of us, right? We've already got it exclusively locked. I can page through my selected rows without worrying about anybody changing things. The disadvantages is, of course, I've got this currently fetched row exclusively locked, so anybody else that's trying to do something to it won't be able to. They'll have to either wait if they have their set lock mode to wait, or they'll get an error back if they try to access it. The other thing, the cursor select statement can't use an order by clause, so you can't sort the data maybe the way you want to with this type of a cursor, an update cursor. Your updates are limited to a single table, and it also can't be defined as a scrolling cursor, which means you can only go one way. You can only go forward with an update cursor. So there's advantages to it and disadvantages to it. Here's an example of using an update cursor. If you have databases that support transactions, you want to be sure to declare the cursor outside the transaction. Right, so you're seeing that here, declaring a cursor, and then they've got the begin work transaction statement, and then open the cursor inside the transaction, which is what they're doing here. They've got the begin work, and then they're opening the cursor and fetching the cursor, or fetching the first row into the cursor. The lock is released when the transaction ends or when the next row is fetched. Right? So even if he doesn't do an update, as soon as he grabs the next row, it's going to release the exclusive lock on the previous row. If your database doesn't support transactions, or if you're not using transaction logging, the lock is released when the cursor is closed or when the next row is fetched, whichever comes first. So that's using an update cursor. That was option 1 to do an update on a row. Now, if you're starting to have a lot of concurrency problems, let's say you have a lot of users, you've got a lot of users making a lot of changes, and you start noticing complaints from the users that they're getting errors, and the reason they're getting the errors is because of these exclusively locked rows out there that might be held for a considerable amount of time while somebody selects, inputs the row, thinks about it for a while, and so on. So we have another method that you can use to update an existing row. I'm calling it option 2, that uses something they call optimistic locking. And all that is that instead of actually locking the row when we select it like we do with an update cursor, what we do instead is just copy all the values from this row that we're selecting into a program record that we're calling a work record. It's just a simple program record like you've been using, except it's just an additional one. So this work record has all the values for our program record as it is when we select the row. But we're not locking it. We're just making a copy of it and put it in this program record. And then we go along, and if the user decides to actually update that row, then before we actually do the update to the database table, we check for the existence of that row in the database, just in case somebody has come along and deleted it since we selected it the first time. And we also can check then with that work record to see if another user has come along and updated that record since we first selected it. And that gives us an opportunity to back out of the change if anything has happened to that row since we started. But we're not exclusively locking it at the time we select it all the way up till we finished our transaction. So that is a reason, or that's the purpose, is to improve concurrency, right? If other people are having a lot of problems because of exclusively locked rows, then this is a method that you can use to kind of work around locking the rows with an update cursor. So the advantages then are better concurrency than we have with an update cursor, but the disadvantage is we have to do more coding. We have to have this work record defined. We have to do a select statement on our database table and copy that row into a work record, and then before we actually update the table, we have to compare the work record with the existing row as it is now to see if anybody else has changed it. Just a lot of different steps required here that are not required with an update cursor. So that would be the disadvantage. There's more work for the developer. So here's the steps to update an existing row if you want to use optimistic locking to try to improve concurrency. We just talked about this work record. So you'll need to define a work record as well as a local record. And then we also have our program record, so we actually have 3 records defined for updating an existing row here. They're all identical. The scroll cursor is defined to let the user scroll through a result set, so not an update cursor, just a scroll cursor. When the user chooses update or modify, the values in the current program record from our scroll cursor, from our select, are copied to the work record, and it's just held there. Then the user does an input, so he can type in his changes to the program record. We use without defaults, just like we normally would, to make sure during the update process that it doesn't change anything with the defaults from the database. It accepts all his information and leaves the information in from the existing row. And then we do an update or an update cursor. Right? We define an update or update cursor and use the primary key in the program record to select the same row into the local record. So now we're doing a select, and we could use an update cursor at this point because the user has already finished all his changes, right? The input statement is complete. So at this point we're ready to update the table, and it should only take just a second or so. So we compare the work record with the local record to see if they've changed since the initial query, that scroll cursor in step 2, to see if it's changed. And if it hasn't changed, that means that no other user has interfered with our row since we did our initial select. And that means it's safe to change it. So if there's no change, we can update the row with our program record values. And again, if you're using Informix, you can use the withhold with your cursor, with your scroll cursor. And then when the transaction is committed, we still have our result set. We still have our cursor open, and the user can keep working. He can still scroll through the result set. Now for most databases, though, that withhold is not supported. So as soon as that transaction, the update is committed, that's going to close the cursor, release the locks, and if the user wants to continue working and do additional updates, he'll have to requery at that point. So here we are doing optimistic locking. Here's the steps where we're going to declare a cursor. So here at this point you can see it's just kind of a code snippet that will fit here on the slide, but the user has already done the input. It's up here somewhere, and here's where we're creating our SQL string here by concatenating our chunks of SQL code together. We saw that yesterday. Got an order by clause. And here we're declaring a scroll cursor from this SQL text, from our string that's been created. So this is probably Informix example, so they've got the withhold here. And then we're opening the cursor, and then we're calling a function called fetch account to fetch that first row. And I don't remember if you remember, but there was a certain flag that we talked about yesterday that you can pass in for a scroll cursor to tell it whether to go forward or backwards. That's the way the application worked yesterday that we looked at. So this one's passing it a 1, so it's going to go forward. And then we're returning back a flag to let us know whether that fetch was successful or not successful. So if it's okay, it was able to fetch the row, we're going to continue. If it's not okay, then we're going to give the user a message that it didn't find anything. And then we're going to return that flag back to the calling function. So here's where we're using that work record we talked about that we use with optimistic locking. So up here we can see we've defined the work record here along with our program record, MR account rec, that we've been working with here in our samples. So here's our work record. We're defining it just like we did our program record. And in here in this function where we actually allow inputs, or I should say inserts or adds or updates, here we're using this work record. We're first setting it to null. And we just saw the logic for an add. So we finished with that just a few pages ago. But now we're going to look at the logic if that flag that gets passed in is a U for update. Right? So the user selected update instead of add this time. So we're going to go down to this else logic. So we're going to give the user a message update account. We're going to assign MR account rec to our work record here, null it out, and then do our input by name that we've seen before. Rats. I was hoping this continued on to the next page here. It should continue. Think of this next page as just an interruption here. Alright, so here's more input control blocks. We talked about input control blocks a few minutes ago for adds. Now here's some input control blocks for updates. So here we're saying this time before field user ID, which remember we said was the primary key for this table that we're working with, the account table. If the AU flag, the flag that was passed into the function to determine whether we're supposed to do an update or an add, if it's U, that means we're doing an update. And we don't want to allow the user to update the primary key. So we're using this before field control block, very handy for saying, oops, you're not allowed to change the primary key, the user ID. So I'm going to pop you into the next field, which is email. You can change this user's email address, but I'm not going to let you change the primary key. So that's a way of managing that. Instead of having to have a whole different function for updates, I can just use this before field control block to keep the user from inadvertently trying to change the primary key. And then here's an on change. We've seen that before. We saw this already. So really in this one we're just focusing on this before field control block. So down here we're checking our int flag. We set it to false earlier in the program, and here we're checking it after our input statement to see if the user interrupted the input, and if he did, then we're handling that gracefully. Operation cancel by user, and then we're setting our program record to null. Uh-oh. Harold tells me that the audio is breaking up, so let me pause for just a moment here. All right. I'm going to put everybody's hands down for a second just to check. All right. Give me a hands up if you're able to hear me okay now. Did it clear up? Okay, I've got several. Okay, very good. Thank you for letting me know. If it does that, please do send me a note, and that way at least I'll stop and won't keep going until it gets better. Sometimes it does that. It fades in and out every once in a while for reasons we haven't figured out. All right. Okay, let's see. Where were we here on this, working with this local record? Okay, so here's our function update account. Here's our local record that we're defining locally in this function, just like our program record and the work record that we saw earlier. And then right here, we're going to do a select statement into this local record right before we do the update. And then we're going to compare this value, or the values that we have in this local record, with our work record right before the update to see if they match. And that's what we're doing right down here. If L account rec dot star equals the contents of the work record dot star, then that means nothing's changed since we started with our select statement early on with the scroll cursor, and it's okay to do the update. Nobody else has been tinkering with this row. So that's how you use a work record along with this local record for comparison purposes to do a check right before the update to make sure that nobody has updated or done anything like delete the row that you're trying to work with. So that's an alternative then to using the update cursor. Here's the actual update statement. Here's our begin work. We talked about using transaction blocks earlier, so there's the begin work for the update statements. Update account, set, and then all the different values here. Or we could use the dot star if all of our program variables and screen record variables matched. And then here we're checking for an error with our update, checking the SQL code. If everything worked okay, we're letting the user know the row was updated with that message. Otherwise, if there was a problem, we're going to set continue OK to false, and that continue OK determines whether or not we continue. So if it's OK, then we're going to commit work. Otherwise, we're going to roll back work. So we're going to back out of that transaction and undo anything we did since the begin work. Now for deleting a row, we've got a special function here in our sample application called delete check. And the purpose of delete check is to go out there and make sure that this row that we're trying to delete doesn't have any existing orders. So that's a good idea if you're allowing users to delete rows and database tables that have detail records, like for example orders and items, for example, or in this case accounts and account orders, then it's a good idea to check before you allow them to delete a row in the parent table to make sure that there's not any child rows associated with it, any detail records associated with it. So that's what we're doing here, this select count, checking to see if there's any child orders. If there's any child orders, it's coming up and saying, nope, you can't delete this account because the account has existing orders. So that's what we're doing here with this delete check. Now if that count comes up 0, right, there's not any orders for the account, then it's okay to delete it. So we're prompting the user here to make sure he's sure that he wants to delete the row. And here this menu is using this special style that we've talked about a few days ago, the dialog style. This is what that looks like. It has a little modal window that pops up there so that you can prompt him yes or no to see if he's sure if he wants to do the delete. And of course if he's sure he wants to do the delete, then we'll do the delete. Otherwise we won't. So we're prompting the user there. So if he's sure he wanted to do the delete, then we're going to call this function delete account, and then there's our SQL to delete that row from the database. So of course we're using the user ID because that's our primary key for that table. And then once the SQL statement is successful here, we give the user a message, and then we're reinitializing our program record back to null. Right, in case we want to start over here again. Might be another record we work with. All right, so that wasn't too bad, about 45 minutes for that chapter. Let me check and make sure I don't have any questions. Anybody have any questions about that chapter? We might just take a short break here, maybe a 15-minute break to put us right up at 12 o'clock Central Time. Alrighty. Okay, well let's go ahead and take a short break. We'll just say a 15-minute break. I don't think we're in particular rush today because we only have the 2 chapters, and then I'll show you a bit about the Genero debugger after we finish our 2nd chapter today, which is on arrays. Okay, enjoy your break, and I'll see you at 12 o'clock Central. Okay, Chapter 10, Working with Arrays. There we go. That's better. So after the end of this module, you should be able to define a form to handle an array, load and display an array to the form, dynamically fill an array, modify data in an array. We have some special built-in methods that we're going to talk about in this chapter that you should be able to use after we finish talking about them, and follow control block execution order. So everything that is an interactive dialogue always has some of these special control blocks. Many of them are the same and have the same functionality. So once you're familiar with a control block with one interactive dialogue, it usually works the same way with an additional interactive dialogue. So what is an array? An array is a series of objects of the same type and size. So you can access a component of an array, an element of an array, with an index like we see here. So this array A, we're looking for the third element in the array, which would be, our arrow's not pointing exactly to it, but it would be 103 would be the contents of that element. You can also have an array of record, which is what we see over here on the right-hand side. So we're pointing here by pointing at this third element in the array, third record in the array, and then you can use the period and then the member of the record to access that specific column of the array or that member of the record in the array. So to display an array, you have to have some special structures in your form that we'll talk about. If you're familiar now with the Office Store application, there's an orders application in the Office Store sample that does use an array to display all the items for an order. So I've got a screenshot of just that part of the orders form here so you can see the actual array. So here they're using a table, which is a common form container that's used to display the contents of an array. That's what this is a table down here at the bottom. And then, of course, inside the form we have to have, or for the form to be able to display to the form, we have to have an associated screen array. So we have a table and a screen array defined. And then the user can scroll through the records in a displayed array, sort on a specific column, and hide and display columns. We don't have to do anything special to code that in the application. That's just built-in features of the display array functionality with Genero. So we've got a screenshot here of somebody sorting by, it looks like unit price. You can just click on the columns when the arrays are displayed to the form to sort by that column. And then here, if they open that up, right-click, they can hide and show different columns if they like. That's all built in. So to define the form, we talked about using a table. So here we have a table container. We talked about table containers some in our form chapter. I believe we did yesterday, if I remember right. So they've added a form here with a table container. Over here is the screen array record in the form structure view. You're familiar now that the screen records always show up in the form structure view. And then all we see over here in our table are just repeating rows of our screen array record. So, and then each column here in our table represents a tag associated with one of those members of the record. If you were using a per file, the text space type form, of course it wouldn't look like this. You'd define the table layout in the layout section of the form, and then you'd have to declare the screen array in the instructions section. So a diagram explaining using an array with a database. So when you were working on your application, you'd have to, of course, define a database connection to the database. Typically, we'd use a cursor and retrieve a result set with that cursor, and then use the for each instruction to fill our program array with data. And then we can take that program array and we can use that program array to display the data to our table container in our form. We can use the display array instruction to do that, or if we want to allow the user to make changes to the data, typically we would use an input array instruction. But later we're going to talk about the display array actually has some built-in functionality now with more modern versions of Genero, newer versions of Genero, probably as many as are still supported anyway. We support options in display array to do adds, inserts, and deletes. So we'll see those here as well. And it actually has a better look and feel, and it's easier to program than an input array instruction. So you might prefer it. Certainly might prefer the way it looks over an input array. So here we are defining the array. This one looks like a defined account array, has a finite size, so that tells us this is a static array. You can define your arrays one of two ways. You can define it as a static array, which has an explicit size like this associated with it, or you can define an array as what we call a dynamic array. And there is no size associated with a dynamic array, and theoretically there's no size limit to a dynamic array. You just fill it and it allocates elements in the array as needed. So really the only limit to a dynamic array again would be memory, kind of a memory dependent type thing. So one thing, if you've worked with arrays before, if you define a static array, what can happen sometimes is you get an array out of bounds error. If you retrieve a result set and it happens that you retrieve more rows than you have defined the size for in the array, then it tries to put more elements into the array than you've sized it to hold, and you get this error, this array out of bounds error. It's a fairly common error when you're programming with arrays. So the maximum size of a static array is this 65535, but again with a dynamic array you don't have to worry about a maximum size. It's only determined by memory. Something else that you can choose between when you're working with arrays, something besides whether or not you're going to pick a static array or a dynamic array, is how you want to load the array and display the data. There's two different modes for that. There's a full list mode, which is what most people are familiar with when you're working with displaying arrays or loading the array. And then there's also a paged mode that you can use. The paged mode is especially useful for really large amounts of data, working with really big database tables, lots of data, and using full list mode actually has to go out there and fetch all of the data right up front and fill the array with all of this data, and it can use a lot of memory if you're working with a really large table. So typically we say now that the full list mode is best used with small result sets that you're working with, short static list of rows, and for large amounts of data, or if you're unsure of how much data you're going to be working with in a table, you should probably use paged mode. So the idea with paged mode is it retrieves rows from the table, what they call a page at a time. Now there's no set size for a page. It's very fluid and changeable based on how much viewable space is on the screen. So if a user uses the scroll bar, for example, that's going to free up some space and retrieve another page of data. So this idea of a page is very fluid and changeable based on real estate on the screen that's available for displaying rows. It'll calculate it automatically, in other words. So we're providing the user with a page of data at a time, and the page can be changeable, and it has a couple of benefits. One benefit is that it uses less bandwidth. We don't have to move all this data from these really large database tables from the server to the client to display the information. So it can reduce bandwidth and, of course, memory, because we're not loading, let's say, millions and millions of rows just in case the user does decide to look at all of them, like we would have to do with full list mode. Instead, we're just retrieving that first page of data, bringing that over and displaying it, and we only retrieve more and use more memory if the user indicates that he wants to look at additional rows. And he can indicate that, of course, by doing things like using a scroll bar, for example, to scroll down. That will retrieve additional pages of data as needed. Or if he stretches the window out, right, just to give himself more real estate, that will also cause additional data to be retrieved, a page of data. So a much more flexible way of working with large amounts of data for big tables. That's the big benefit of paged mode. So here's an example of full list mode. I've got this function called show accounts where we're defining a cursor here to retrieve data from the database, user ID, first name, last name. We've got some built-in functions that we're going to see in this show accounts function that we can use to work with arrays very easily. We don't have to do as much programming as we used to have to do to work with arrays. So we've got this built-in function here called clear, or built-in function just for arrays. So the name of the array here is account array, ACCTARR, and we're using this clear built-in function to go ahead and clear out the array. Now that behavior will be different depending on whether you're using a dynamic array or a static array. If it's a dynamic array, it actually does remove all the elements in the array, because dynamic arrays, remember, just add elements as needed if you keep adding things to the array. Whereas a static array, all those elements are already there, the memory is already allocated, so this clear function just goes in and sets all the elements to null in the static array. So that's a built-in function. Then typically to load the array, we're going to use a for each here, and so going to use this for each with the cursor to retrieve the result set one row at a time and load it into the array with this other built-in function, append element. Now this append element function is only used with dynamic arrays, and what it's doing is adding an element to our dynamic array for every row retrieved from the database that we're using to fill the array. So that's adding elements to the array one element at a time as the rows are retrieved and used to fill the array. And then here we've got let account array, and here's another built-in function, account array.getLength, and that of course determines the length of the current array or the array associated with the function, and then we're associating it with that new record. So we're adding elements to this dynamic array, and then that new element that's been added, we're figuring out where it is by using this getLength function, and then we're assigning this record that we've retrieved from the database with the for each to this new element. So that's how we're loading the array. We're using a for each to retrieve data, put it in a program record, and then we're copying the program record to this new element of the array. And then once we're finished loading the array with the for each, then we can display it with this display array statement to display it to the screen. So here's a diagram explaining paged mode a little better. Here we've got a database connection that we're going to use to retrieve rows from the database to fill the array. We're declaring and opening a cursor. In this case we're using a scroll cursor. And then the dynamic array is what we use with paged mode. It requires a dynamic array. Holds one page of data, and a page is just predetermined or pre-calculated to fill the available real estate that we have there in the table container. So that's what the page is. It's no predefined size. So display array, and here's the trick to paged mode. It's a statement called onFillBuffer, and that's what causes it to retrieve additional pages is if the user does something to trigger this onFillBuffer. Now initially that onFillBuffer fills the available space on the form with a page of data. And at that point, that's all the data it retrieves until the user does something to initiate an additional on-fill buffer. So again, he could scroll down, he could stretch the window out, and all of those types of actions by the user will trigger this on-fill buffer clause, and it will go ahead and retrieve an additional page of data. So here's an example of the code that you would use to implement paged mode. Here we're declaring the scroll cursor. Here's a select statement that we're using to retrieve the results set, opening the cursor. And here we're displaying the array. At this point, the array doesn't have anything in it, but we're just issuing the command to display the array to the screen record. And then here's our on-fill buffer that actually is going to retrieve that first page of data, that first page of rows, to display to the screen array. There's a couple of built-in methods that we can use here. This FGL dialog get buffer start is used to go out and figure the offset into the results set from the cursor for the next page of data. So that's what the get buffer start is. It's getting an offset into the results set. Where are we now, and what do we need to grab after this? And in this length here is using this FGL dialog get buffer length method to go out and figure out how big the page needs to be. So that's the number of rows that it needs to retrieve to fill the available real estate that's freed up. So this on-fill buffer, anytime the user, let's say, expands the window or uses the scroll bar, it's going to use these two methods to figure out an offset and a size, number of rows, length, that it uses for the next page of data to bring in. So fortunately, we don't have to code that. We can just instead use these two functions or built-in methods. So here we're just saying let row equal the offset that we had by using this built-in function to get the buffer start. I keep using the terms function and method interchangeably, don't I? Built-in function. And then for I equal 1 to length, fetch absolute row. Right, so that's been determined to be the next row in our results set that's needed for the display. And we're loading that into our array. So that's page mode. We're just grabbing a page of data at a time, and we've got these special functions, built-in functions, to help calculate which rows we need to grab and how many of them to fill up the available real estate. So from here we're moving to input array that you can use to modify a list of rows, right? To modify the rows or records or elements in an array, however you want to think of them. When you're working with database tables, sometimes it gets a bit confusing, but you're working with array elements. So here we've got an input array. It's going to allow the user to edit or delete existing rows. And this is another one of our interactive dialogues that has some built-in functionality, some built-in predefined actions. So this automatically has some special actions for managing our screen record, so that if a user goes in here and does a delete, for example, which is a predefined action, if the user goes in and does a delete, the screen doesn't look funny because we've got this missing row in the middle, just an empty space, for example. So we've got some built-in functionality to actually go in and delete records from the screen array so that we don't have this empty space. We'll see that all here in a moment. So here's an example or more discussion on input array. Syntax up at the top. Input array, example here is country array from srcountry.star. So we're loading that array. And in attributes without defaults unbuffered. Or actually we're inputting this array from a screen record called srcountry.star. So just like all the other interactive dialogues that we've talked about, these interactive dialogues temporarily bind the screen array record with your program record for the purpose of being able to manipulate things on the screen or in the form. So again, the number of variables in each record has to be the same as the number of fields in the screen record. And each mapped variable has to have compatible data types as a corresponding field and a compatible size. We've got the without defaults clause again here and the unbuffered clause. I won't explain those again because we've seen them already, I think, twice today. So here's more about these predefined actions that come along with the input array interactive dialog. There's predefined actions to handle any inserts, deletes, or appends that the user chooses to do. If the user chooses to do an insert, this predefined action will automatically insert a new row before the current row that the user has selected on the screen. That's the current row. And then it'll insert that field record into the program array automatically. So it does all of that for you so that you don't have to code it. So predefined actions to do this. And then the same thing for delete. There's some predefined actions there that does just the opposite. It deletes the current record from the display of the screen array and program array, and then it even redraws the screen array so that that deleted record disappears. If the user deletes it, you don't want it to still show up on the screen because it would be very confusing for him. So this handles that for us. And then an append adds a new row, very much like an insert, except since it's an append, it's going to be at the end of the list at the bottom, and then it also, of course, inserts the data for us into the program array. So all of that coding is done for us. We've got control blocks for input array, just like we do all the interactive dialogues. Here's one that's commonly used, the before delete. If you have a user that wants to delete a record, what they're really doing is deleting it from the screen array and the program array here. But what we typically do is use this before delete control block so that if we're working with a database, we have the opportunity to go in and delete the row in the database associated with that screen record before it gets deleted from the screen record and the array. So that's a very useful control block if we're working with databases. So that way the values are not deleted from the program record or the screen array until we get a chance to delete them from the database table first. We need the values right in the program record to be able to locate the row in the database table to delete it. Earlier I mentioned that it's not very intuitive, but display array can also be used to enter and modify data. Not just display array data, but modify and delete array data. And it actually has a more modern look and feel to it than the input array interactive dialog. So here's what the display array looks like. It has a pretty modern look and feel to it. The whole row in the screen record, the screen array is highlighted here, which is what users are more accustomed to seeing. When you're using input array, it just focuses in on whatever field the user has selected is highlighted, but not the row going from left to right. So this actually has a better look to it, I think, than the input array. But to use display array to be able to modify data, we have these special things they call modification triggers. They're right here. This on update, on insert, there's an on append, and an on delete modification trigger. So these modification triggers actually switch over from display mode to update mode so that the user can modify data just as though he were in an input array. They're easy to code. Notice you just have your on update, for example, here, and then you can put your input statement here to allow the user to actually just do a simple input from a screen record. Here's the on insert, which is exactly the same thing, and then on append. And then again, just like the input, the input array. It's handling all the screen drawing and deleting from the program array and the screen array automatically for you. You don't have to do any of that coding. We've seen a lot of these. This is specifying all the built-in methods. So I was using the term method and function interchangeably. I should have been just using methods. But here's all these built-in methods for arrays. I think I got them backwards, didn't I? But there's the append element that we saw that you can use to add a new element at the end of a dynamic array. Doesn't have any effect on a static array because all of the elements in a static array are automatically allocated as soon as it's defined. Here's the clear that we saw earlier, that the effect depends on whether you're working with a static array or a dynamic array. And we said for a static array, it sets all of the elements to null in a static array, and it actually removes all the elements in a dynamic array. Here's a delete element. I don't think we saw the delete element built-in method earlier, but the idea with the delete element is if we allowed the user to do a delete, this is what's happening underneath the covers. We can delete that element by specifying with an integer here. And in get length, we did see that. That returns the length for a one-dimensional array. And then here's the insert element, which we did see earlier in the chapter. And that inserts a new element at the given position, which we've defined here as an integer. Okay, that wasn't too bad, about half an hour for that chapter, so it's 12:28 Central Time. We still have plenty of time left, I think, to go ahead and show you a bit about the graphical debugger. That was one of my goals today, and you do have a lab for the graphical debugger. Now, whether or not that lab works perfectly or not, or whether you'll have to improvise a bit when you're working with it, depends probably on what version of Genero Studio that you're working with. If you're working with the same version that I was working with when I wrote that lab, then every step in the instructions should work okay. But I'm going to assume that we might have different versions that we're working with, so I tried to rewrite the lab to be a bit more flexible for that. So if you look in the materials page, you should see an updated lab in there that for the debugger part. So if you don't find that, send me a note and I'll give you the name of it, or email it to you if you're unable to download it. But let's take a look here at the debugger. Since we were working with the accounts table and all of our samples today are looking at examples from accounts, I'm going to use that for my debugger example instead of Office Store. All right, so let's see here. Let me stretch this out so we can see it better. When you're working with the graphical debugger, everything kind of starts with what they call a breakpoint. So to start the graphical debugger, the first thing you do is go in and look at your code. I usually start right from the beginning with the main, and I just scroll down until I see something interesting. Maybe I'm trying to figure out what this program does, and so I'm curious. For example, here this menu is, and one of the first thing it does is if a user triggers the query action, it's calling a function called query account. So I'm going to set a breakpoint on that function call so I can see that a little clearer when I actually run the debugger. So I can do that by just clicking over here in the gutter. Right, I can click to create a breakpoint. I can click again to get rid of it. The other way is to right-click, and you have an option when you right-click on a line of code. There's an add or delete breakpoint option there, or even a disable and enable breakpoint. A lot of times you'll be working in the code and it's reiterative. It keeps going into the same function over and over again. You may not want to have a breakpoint on that function every time because you've figured out what that function does at some point. So now you're ready to continue on without stopping at that breakpoint every time. So you can disable it or delete it if you like to get rid of it once you've figured out what's happening in that function or wherever that breakpoint is. So there I've got this first breakpoint. Now something that's pretty handy for setting breakpoints, let's say I decide I want to set a few more. So one thing I can do here is I can look over in the code structure view. And the code structure view tells me all the modules here that I'm working with, and then all these functions. So here's my module, accounts.4gl. Here's my functions. They're calling main a function in this case. And then here's externals. These are all external functions. So what I can do to easily set a breakpoint, let's say I'm curious about this fetch relative account. I don't know what that does. I can click on that, and that brings it up over here in my code editor view. And what it does is it opens the module that that function exists in, which is this accounts.mate.4gl for me, and then it brings it up so that that function that I've selected in the code structure is current. So I can just add a breakpoint to it right there. So you can use the code structure view to quickly find functions if you want to put breakpoints at different function entry points. So that's a handy method. All right, so let's say that's enough breakpoints for me to get started. So I'm ready to do some debugging. So I'm just going to right-click on the application, and this time instead of selecting Execute, I'm going to select Debug to get my debug session started. Now when I select that debug option, stretch this out. There we go. Notice that I get a bunch of new views here. So in addition to my code editor and code structure views, now I've got this data view down here and all these other tabs that I can use to look at additional debugger views. So the data view has all my variables, local variables, user variables that I can actually set for myself. I'll show you how to do that in just a minute. There's nothing special about that, but local, modular, and global variables. Now there's nothing there yet because I haven't really gotten started with this application. Here's a list of all my breakpoints in the breakpoint view, and I did set a couple of breakpoints. So I've got the module here that the breakpoint's in, whether or not it's enabled or disabled right now, the function that the breakpoint exists in, which fetch relative account and main. Conditions I'll show you in just a moment. And then hit count is how many times we've actually encountered that breakpoint. Well, we haven't encountered either one of them yet. We haven't executed the code enough to get there. That's probably good for the moment, I think. And then we'll look at some of this other as we go along. Here in a minute, there'll be some data here in the backtrace view that we can look at. The backtrace is so that you can see where you've been in an application, which functions have been called, and the sequence of those function calls, and which function is currently the function that the code is working in. You can see all that from the backtrace view. And in the command view right up here is where you can see a command history, all the different commands that you've issued to the debugger, and you can actually see some of the results of those commands in the command view as well. So I've got a lot of different views with the graphical debugger. All right, so whenever I started my debug, let me pop this up here, it has managed to make it far enough in the code here to open my form, right, to open and display the form. There's nothing in the form yet, but it's sitting here. Now something that we're seeing here is when the debugger reaches an interactive instruction in the code, which is what's happened here, it turns control back over to the user, just like a normal program execution would do. So I'm in the debugger, but I'm also just running this application normally to a certain degree. So right here, if you look up at the top, notice in my toolbar that has all my debugger commands, we'll visit these here in a moment, none of these debugger command options are enabled except the interrupt. So I could interrupt right here, and that will interrupt the interactive dialogue and pop me here to the current interaction, right, which is this menu statement. So now I can see exactly where we are in the code. It's sitting there waiting for the user to select an action, right, to select an action. So here this green arrow is pointing to my current statement. So here I'm going to get things started by picking query. So I pick the query. Nothing's happening because we're sitting there waiting. So the debugger's wanting me to tell it what to do. So now notice that up here in my toolbar, all my debugger options are enabled again. So this one here, if you hover over it, it should go ahead and tell you what it is, although for some reason it's not doing that today. So let me go up here to the debug menu. So up here in the debug menu, you've got this next option. So this one here on the left that I had highlighted that for some reason wasn't showing us the helper, the hint, is next. I've got a step in option that I use to step into a function. So when you're working in a debugger and the lines of code are getting executed and the next line is a function, you can step into that function so that it actually shows you the code that's being executed in the function, and you can step through it line by line if you want to. If you don't step into the function, unless you've put a breakpoint there at the function entry point, you won't see any of it. What you'll see is when it comes back out of the function and it's finished with it, you'll see it go to the next line in the code of the function you're currently watching. So that's what the step in, and I'll demonstrate that here in a minute. Stepping out, of course, just steps back out of the function. You don't really want to go through the whole thing after all. So that way you don't have to step through it line by line. Continue will go ahead and continue execution of the program until it reaches a breakpoint, or what we call a watch point, which I'll explain here in a second, or an interactive instruction, like we saw with this menu statement that was current. All right, so that's kind of the debug menu options, and these are the toolbar icons, so once you get familiar with them, you might prefer them instead of having to go to the debug menu and picking them from the menu all the time. All right, so here we are in the menu, and it's still waiting for me to do something here. It's waiting for me to tell it what to do. So I'm going to say, go ahead and do a next. So I clicked next, and now I can see I've got some, nope, not just yet. All right, do it again. Here we go. Now then, we've got call query account, getting ready to call this function. And I've got a breakpoint here, so it's stopped here, and it's waiting for me to tell it again what to do. It's not going to go ahead and process the function until I tell it one way or another. So what I'm going to do here is step in. We talked about the step in option because I want to see that function execute. So here I am stepping into the function query account, and I'm just going to walk through it step by step. So here it's executing one step at a time. Let continue OK equal false. Construct by name where clause. Here we are in a construct, doing a query by example. And when I click next again, notice that everything's disabled again except the interrupt. And that's because, once again, just like the menu statement, we've reached an interactive dialogue in the code where we've turned control back over to the user. So if I open my form back up, here it's sitting here waiting for me to input some data. Oops, didn't mean to do that. All right, so I can't think of a valid user ID right now, so I'm just going to click OK, which is the equivalent of saying everything, right? That 1 = 1's special Boolean for SQL that means return all rows. So now at this point, I'm just going to take a peek down here at my variables in my data view, and notice now I've got something to look at because we've got some data. So here these exclamation marks are telling me that there's been some changes to these variables to get my attention. And here I can see that this where clause, that's our string variable that we've been talking about in a lot of our sample applications, has had a change to it, right? The variable value has changed. So now the value is 1 = 1 because I just clicked OK a second ago, which equates back to this 1 = 1 special Boolean. So that means retrieve all rows. And here it's waiting again for me to tell it what to do. So I'm going to go ahead and click Next. It's going to call another function called getAccountCount and pass it our new where clause that's just been cobbled together. And this time, instead of stepping into the function like I did last time to show you that you could watch it step by step, I'm just going to continue here or click Next. And notice that I don't see that function. It just assumes that I'm happy coming right back to the line following the function call. So when I don't step into that function, I don't get to see exactly what's happening in there. So I have no idea what happened in that function because I didn't step into it. And there'll be functions where you do want to step in and see it, and others you know perfectly well what they do, and you're not interested in seeing every single line of code. All right, so there's that. So notice if I look down here after processing that get account count, it obviously went out and got a count, did a select count. And if I look in my data view, I can see that this local variable account count has a value in it now of 6, which tells me that it retrieved 6 rows, or it found 6 rows that met my search criteria. So if I continue down, I'm just stepping through, sending the user a message, call account select. Let's step into that one so we can see exactly what happens. So I'm going to step in, and there we are now. We can follow along what happens in this function. So there we are. There's our SQL text variable that we're using to create our SQL statement. Concatenate the whole thing together. Declaring a cursor so that we can go out and fetch those rows that meet our search criteria. And here they're calling this function called fetch account and telling it to fetch the first row. And here it's saying if not fetch OK, then message no rows in the table. So let's see what fetch OK is. And it looks like fetch OK is OK, right? It's set to 1. So it skipped right over this message because fetch OK was OK, and now it's going to return it back to the calling function. Now before we let it return, let me show you something else that you can do here. Before it returns that fetch OK, let's say that I'm here trying to figure out what the behavior would be if there was a problem. So I can actually edit this variable value, and I'm going to change it from OK, which was a 1, to a 0. And notice now the value of that variable, I've manually manipulated it to cause it to not be OK. Nothing was good about the fetch. So now if we go ahead and continue, it says OK. If continue OK is true, then I'm going to display, called display account, and display those records. Let's see if it does. It didn't, right? So it skipped right over this call to display account because I manually manipulated one of my variable values here with the debugger and set it to not OK. And essentially I've changed the behavior of the program so that I can maybe study a bug a little closer or manipulate it so that I can force that bug to happen, right? I can duplicate the bug by using those variables. All right, let me show you something else. What's a watch point? A watch point causes the program to halt, right, like a breakpoint does. It stops execution when the value of an expression changes. So what you can do is, let's say I'm interested in this where clause. Trying to think what to set it to. Okay, let's not worry about that yet. I'll just add it to watch. If you right-click on it there in our data view, there's an option to add it to watch. So now I've added it as a watch point. So if I click on my watch points view, there it is. There's this variable that now is an expression that's being watched to see if the value changes. So now if that where clause value changes, that should create the equivalent of a breakpoint, right? It's going to stop program execution so that I have a chance to look at that more closely. So that's what a watch point is. You can use that to track variables and stop execution when the contents of a variable changes. All right, so let's just go ahead and continue here. So again, it's waiting for us to do something. So I'm going to do a query. And that's still waiting on me to do something because I've got this breakpoint up here. I'm going to get rid of that breakpoint. Now I'm going to tell it to continue. And here again it's waiting for me to do something. So I'm going to type something in here, bogs, and click OK. And now I'm just going to hit this button. I don't think I've used it yet, so I'm going to do it. See, it's the continue button. This says continue until you hit a breakpoint, a watch point, or an interactive dialogue, right, where I have to input some information to continue or interact to continue. So I'm going to hit the continue option. And when I didn't get very far. Notice that my query didn't really do anything. And here it's saying, aha, the where clause has changed. Now it's no longer 1 equals 1 like it was before. Now it says, oh, the account.userid equal bogs. So that watch point will cause execution to stop because this expression that we're watching has changed. All right. That's about all I can think of really to get you started with the debugger. Those are some commonly used steps or processes to get into the debugging mode there. Let me show you, though, a few other things while we're in here that are not directly associated with the debugger but have to do with debugging. Something here called an open dependency diagram option. So if you click that here in your project view, this is a small application or a small group of applications. There's not a whole lot here, so it's not going to be much to see. But if you expand it, you right-click and expand it, you can see all the applications here. And what we're trying to find out is their dependencies. So for each application, I can expand further. And I can see, for example, that the accounts application, the dependencies are this accounts and accounts mate modules. So it has 2 modules in it, according to this view. Now something else you can do is, let's say you're working with a real application, not just this little application we're using for class, and there's just way too much stuff on the screen for you to figure out what's going on. It has this filter items option, where I can go in and get rid of all this extraneous stuff that I'm not interested in. So I'm going to get rid of all the information about any of the applications except just this accounts application to simplify the screen. Now here it doesn't make that much difference, but in a large application you can see where this would make it more manageable for you to see what's going on. Now from here, one thing I can do is select this little arrow right here. Let me raise that up so you can see it. And what that does, you know, the line and the arrow are indicating a relationship between this module and this module. So if I click on that line, it's going to show me all the functions and how they're associated. So here, notice I have this new function call view. Spread this one out. So I can see the caller function, looks like it's all going from this direction to this direction, accounts to accounts mate. So the caller function in each case is main, and it's calling functions in this accounts mate module. The called module is accounts mate. The caller module is accounts.4gl. The caller function is main. I think I said that backwards before. All right, so there's all of our functions. Now from there, you can even go further if you want to. Like if I click on a function, what have I done here? Interesting. Oh, I think I know what's wrong. Well, it's being very stubborn. What I was trying to see, let me try this again. Trying to show you a sequence diagram. It was being a bit stubborn about that, so let me try again. There we go. All right. Doesn't like the double click, but it likes the right click. All right. So right click, open sequence diagram. You can tell I don't do this that often. I have to really think about it. Now this thing is called the sequence diagram, so it's showing you the sequence of function calls and where the user is entering the application and then the sequence of function calls from that point. Now here it's showing you that we've got this function called getAccountCount. Then we go from there to account select and then display account. Anywhere where you see the plus symbol, that means that it can be expanded further. There's a show subcalls. For some reason I keep trying to click on that, but you need to right click and then you can see the subcalls. So this account select then in turn calls fetch account. And at the same time here in your structure view you can also see that relationship as well. So that's the sequence diagram. So some additional tools that you can use to explore or get more familiar with an application. So all of those are tools to help you figure out exactly what's going on. That's nice if you inherit a big application from someone else. All right, so I showed you a bit about the debugger, enough at least to get you started with the debugger. And we talked about dependency diagrams that you can look at by right-clicking over here in the project view. There's an option to open dependency diagrams and see the dependencies. And then if you select on a function from in there on one of those lines between the modules, it shows you all your function calls between the two related modules. And then we also looked by selecting a function at the sequence diagrams. All right. Okay. Well, I think that's probably good for today. We've been at it a while. Do I have any questions before I let you go today to work on